Hello students, how are you? I hope all of you are fine and healthy. In the last class, we have completed exercise 10.4 and today we are going to know some important theorems. But before that, I want to tell you that I'm not happy. Why? Do you know? Because I'm not getting homeworks from all of you. So I request all of you, please submit your homework. In case any doubt, please contact me. So let's start the class. Okay, so today we will discuss angle subtended by an arc of a circle. This is a new concept for you. So before that, you have to understand this node 1 and node 2. See, suppose AB and CD are equal chords. AB and CD are equal chords. If two equal chords of a circle are equal, then their corresponding arcs are congruent. And conversely, if two arcs are congruent, then their corresponding chords are equal. That means you can see this chord AB and chord CD. So corresponding arcs are congruent means this arc AB and this arc CD. Okay, if AB is equal to CD, then their corresponding arcs are congruent. Or conversely, you can say that if the corresponding arcs are congruent, then you can write AB is equal to CD. Means chord AB is equal to chord CD. Note 2. Congruent arcs or equal arcs of a circle subtend equal angles at the center. Here, congruent arcs of a circle subtend equal angles at the center. So here suppose the angle subtended by arc AB, since if you have that arc AB and arc CD are congruent, then angle subtended by arc AB is equal to angle subtended by arc CD. Okay, now angle subtended. So I hope all of you understood this one, the congruent arcs or equal arcs. If arc AB is equal to arc CD, then angles subtended by this arc are also equal. Theorem 10.8. The angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. See, suppose this is arc AB. Okay, angle subtended by this arc, okay, angle subtended by this arc at the center, so O is the center of this circle, is double the angle subtended by it any point on the remaining part of the circle. That means if this arc will again subtend one angle on the remaining part of the circle, suppose here you can take anywhere on the circle, suppose this one. Okay, then you can say that suppose this is angle P and measurement of angle, this is suppose angle, this is X, this is Y. Okay, angle X and this is Y. Then you can write the angle, according to this, the angle subtended by an arc at the center is double the angle subtended by it any point on the remaining part of the circle. That means angle Y is equal to twice angle X, means double of angle X, double of this angle. Or you can write angle X is equal to half of angle Y. Clear? So so when I have explained note 2, so now you will understand this one easily. Angle subtended by equal arc. Suppose this is AB and this is CD. This arc AB and arc CD are equal. If they subtend angle at the center, suppose this angle and this arc subtended angle is here, this one center. So you can write this angle and this angle are equal because the arc CD and arc AB are equal or congruent. Then you can write these angles are equal. This is called congruent arcs of a circle subtend equal angles at the center. But in this case, you can see there's angle subtended by this arc AB at the center. Again, by this arc, if you get an angle on any part of the circle, then this angle will be the double of this angle. I hope all of you understood. Next, Theorem 10.9. Angle in the same segment of a circle are equal. segment. Okay, see, suppose this is chord AB, then what is the name of this part? This is a segment. Yes or no? Then if for this segment, what is called angles in the same segment of a circle are equal. Angle formed by this segment, subtended by this segment, there are two angles you can see. Angle subtended this one AB, suppose this is P and this is Q. Okay, then you can get these two angles are equal, and this is called angle in the same segment, because from the segment you get two angles, this one and this one, and according to this theorem these two angles are equal. Okay, so if we use this one in the case of semicircle, suppose AB is diameter, then this will be the what? Semicircle. This is the center. Then what is the measure of this angle? 180 degree. Yes or no? Then angle subtended by this arc at the center, this at the center is 180 degree, and angle subtended this arc by AB on the circle is how much? This will be half of this, means if it is 180 degree, then this is 90 degree according to this theorem. So that is why you can write this one, angle in the semicircle is how much? 90 degree. Clear? Now cyclic quadrilateral. So first of all you have to know what is cyclic quadrilateral. A quadrilateral ABCD, suppose you are having a quadrilateral ABCD, is called cyclic when you can say this is cyclic if all the four vertices of it lie on a circle. See in this figure, A, B, C, D are lie on the circle or not? Then ABCD is called cyclic quadrilateral. So theorem 10.11, the sum of either pair of opposite angles of a cyclic quadrilateral is 180 degree. That means sum of angle B plus D is 180, sum of angles A and C is 180 degree. The converse of this one is also true, that if the sum of a pair of opposite angles of a quadrilateral is 180, then 180 degree, the quadrilateral is cyclic. Suppose you are having a quadrilateral like this way, all the four vertices lie on the circle, and you are having the sum of the opposite angle is 180 degree, then you can say that it is a cyclic. If cyclic, then the sum of the opposite angles is 180 degree. If sum of the opposite angle is 180, then you can say it cyclic quadrilateral. Okay, so I hope all of you understood, because these things are very, very important. Before starting exercise 10.5, we need to understand all these theorems. Okay, that is why today I am not going to give you any homework. Just go through it and try to understand all the theorems and all the concept of these theorems. In case any doubt regarding these theorems, then please get back to me in the evening. Okay, in the next class I will start exercise 10.5. Thank you. Have a great day.